Today we are learning about stoichiometry. Stoichiometry is the calculation of the quantities of chemical elements or compounds involved in chemical reactions. Now, if that sounds confusing, here's an example.
A chemical equation is similar to a recipe. Both list ingredients and products. Also, both can be used to determine the amount of an ingredient needed to produce a certain amount of product, or use up another ingredient. We will use cookies to demonstrate stoichiometry.
First, let's start with the recipe. The ingredients, or reactants, are 2 eggs, 3 cups of flour, 1 teaspoon baking soda, 1 teaspoon salt, 1 cup of butter, 1 cup of white sugar, 1 cup of brown sugar, 1 teaspoon vanilla, and 2 cups of chocolate chips. These are all mixed together to produce cookies!
An important part of stoichiometry is the mole ratio. This is defined as the ratio of moles of one substance to the moles of another substance in the reaction. To find the mole ratio, you simply look at the balanced equation. This is a sweet topic, right? We can demonstrate how the mole ratio works in a recipe for cookies.
Let's use the example of flour and sugar. In this recipe, there are 3 cups of flour to every 1 cup of sugar. You can show this mathematically by starting with the cups of flour and converting to sugar. It's important to remember units. Whatever unit that's on top of the equation should be in the bottom on the next equation. You do this so that unit can cancel out. As you can see in this equation, the mole ratio of flour to sugar is 3 cups of flour to every 1 cup of sugar.
Another part of stoichiometry is the limiting reactant. This is the reactant in the reaction that limits the amount of product that can be formed. As you can see, we have 3 eggs. However, we have this whole bag of brown sugar. How many batches of cookies can we make with these 3 eggs and this brown sugar? What will be the limiting reactant?
Let's say we have 3 eggs. Start with that on top. In the next step, write how many eggs are needed for 1 batch in the bottom. 3 divided by 2 is 1/2. Therefore, you can make 1.5 batches of cookies with 3 eggs. We also have 5 cups of brown sugar. Again, this part goes on top of the equation. Write how many cups are needed for 1 batch. As you can see, 1 cup of brown sugar is needed for 1 batch of cookies. 5 cups divided by 1 cup is 5. Therefore, we can make 5 batches of cookies. We can make 5 batches of cookies with the brown sugar we have. However, we can only make 1.5 batches of cookies with the eggs we have. Therefore, eggs are the limiting reactant, and we can only make 1.5 batches.
You can also use stoichiometry to convert a different unit to moles. The recipe calls for a certain number of teaspoons of vanilla extract. However, the other units are usually given in cups for this recipe. Let's say 1 cup represents 1 mole.
Let's convert teaspoons to cups. After some research, we find out that there are 48 teaspoons in a cup. To start your math, put the known quantity on top in the first step, which is 12 teaspoons. Next, put the unit teaspoons on bottom on the next step so the unit of teaspoons cancels out. There are 48 teaspoons in a cup, so put the 48 teaspoons on the bottom and 1 cup on top. 12 divided by 48 is 0.25. Therefore, 12 teaspoons of vanilla extract makes 0.25 cups. So, to review, the mole ratio is the ratio of moles of one substance compared to the moles of another substance in the reaction. As you can see, the ratio of brown sugar to chocolate chips is 1:2. Therefore, if we have 3 cups of brown sugar, we can use the mole ratio of 1 cup to brown sugar to 2 cups of chocolate chips. And we see that we can produce 6 cups of chocolate chips. The limiting reactant is the reactant that limits the amount of products that we can make. In this example, we have 6 cups of flour. We need 3 cups of flour for 1 batch. So, using stoichiometry, we can see that with 6 cups of flour, we can produce 2 batches. We also have 5 cups of sugar. However, we only need 1 cup of sugar for each batch. That means with our 5 cups of sugar, we can produce 5 batches. 5 batches is more than 2 batches. Therefore, flour is our limiting reactant. Converting units is when you convert one unit to another unit, such as converting teaspoons to cups. In this example, we have 24 teaspoons. We know that there are 48 teaspoons in a cup. So how many cups can we produce from 24 teaspoons? While using stoichiometry, we can see that 24 divided by 48 is 0.5. Therefore, we can produce half a cup from 24 teaspoons.
This may seem like a fun and easy process, but it's no pizza cake. It can also translate into the formation of real chemical equations.
Hey ladies, now let's get information.
Now that we've learned the basic progress of stoichiometry, we can use what we've learned to solve real chemical equations. For example, let's look at the formation of ammonia. The balanced equation of ammonia is 1 mole of nitrogen gas mixed with 3 moles of hydrogen gas produces 2 moles of ammonia. The mole ratio of hydrogen to ammonia is 3 to 2. Let's say we have 6 moles of hydrogen gas. Using the mole ratio of 3 to 2, we can see that 6 moles of hydrogen gas produces 4 moles of ammonia. Now let's try a limiting reactant problem. Let's say we have 9 moles of hydrogen gas. We also have 5 moles of nitrogen. The mole ratio of hydrogen gas to ammonia is 3 to 2. So 9 times 3 divided by 2 is 6. That means we can make 6 moles of ammonia. The mole ratio of nitrogen to ammonia is 1 to 2. So 5 times 2 equals 10. Therefore, we can make 10 moles of ammonia with 5 moles of nitrogen gas. 10 is greater than 6, so hydrogen gas is our limiting reactant. Lastly, let's work on a converting units problem. We can also find the grams in a mole. This is called the molar mass. We can find the molar mass for each element on the periodic table. The molar mass of hydrogen is 1.01 grams. To become more stable, it bonds with another hydrogen atom. So the molar mass of hydrogen 2 gas is 2.02 grams. Let's say we start with 12.12 grams of hydrogen gas. Divide our given 12.12 grams of hydrogen gas by our molar mass, 2.02, to get the number of moles of hydrogen. Now that we are in moles of hydrogen, we can use our mole ratio to convert from moles of hydrogen to moles of ammonia. The mole ratio of hydrogen gas to ammonia is 3 to 2. Multiply the top side and divide that by the bottom side. This will give you the moles of ammonia. 12 grams of hydrogen gas gives us 4 moles of ammonia.
Thanks for watching!